Hello, and welcome back to the Did You Get It videos. This is from lesson 3-2. It's all about compound interest. And this is the lesson that you're going to turn to. We're going to be using, starting with this basic formula for compound interest, compounding annually. And these letters will always represent the same pieces of information. A is going to be our future value. P is the principal amount, which means either the amount we invested or lent to the bank or the amount that we borrowed from the bank. R is the interest rate, always in decimal form, and T is the term in years. So if you're given the term is how long you're going to take to pay back the money. In years, you need to translate that from months to years or days to years. So it always needs to be in terms of years. So did you get it? Number 1 is on page 273. For an investment of $100,000 at 6% interest for 4 years, find the simple interest and the compound interest if interest is calculated once per year. Okay, so we need to write down that P is 100,000. R is 0.06. And T is for 4 years. So A is simple interest. Simple interest, we learned in lesson 3.1 that it's equal to PRT. That's the interest for simple interest. So we will go to Desmos and put in 100,000 times 0.06 times 4. And then compound interest, we have to find by taking, we're going to have to find the future value and then subtracting the original amount, and that will tell us how much total interest we've earned over the 4 years. Okay, so let's go ahead and go to Desmos. And you should have your Desmos open as well. And I'm going to title this number 1. And so our simple interest is going to be 100,000 times 0.06 times 4 years. So the simple interest is going to be 24,000 over the 4 years. Now the compound interest should be number 1. The compound interest is going to be the 100,000 times 1 plus the rate, which is 0.06. And then if you use your shift and your 6 key, you can do the exponent here, and that is going to be to 4. So this is how much money we will have after 4 years. This is our future value. $126,247.70 if you round appropriately. So 126, 247, and 70. And then if we subtract away the original 100,000, you can see that the interest after that 4 years is equal to the 26,247 and 70 cents. And also I would save this in your Desmo so you have it to go back to. So this was our interest for the simple interest was 24,000, and this was our compound interest after 4 years. And we only compounded annually. Once a year. Okay. So let's look at, did you get it, number 2? Did you get it? Number 2 says, find the interest on an investment of $75,000 that pays 4.5% compounded weekly for 8 years. So remember, whenever you're doing compounding and you want to find the interest, there's no way to just calculate the interest with a formula. You must always find the future value and then subtract away the original investment. So if we want to find the interest, we have to take the future value and subtract P. The original principal. So our future value here, we're finding the interest on an investment of $75,000. That's P. And then this is our rate, and compounded weekly means the N is going to be 52 because we have 52 weeks in a year, and then this is going to be T. So that means we're now using, for our future value, we're using this formula here where we have N is the number of times that interest is compounded per year. So we're going to use P times 1 plus R over N to the NT. And so in this case, it's going to be 75,000 times 1 plus 0.045 divided by 52 times, usually it'll be NT. I just wrote it opposite. So 52 is N times T is 8 years. Okay, so let's go to Desmos to find out what this is. Okay, so this is going to be 75,000 times 1 plus, and then 0.045 divided by 52. And then you're going to shift in 6. And then because we have multiplication going in the exponent, we have to put that in parentheses. So it's 52 times 8. So it stays together. So our future value is going to be $107,482.97. And then we're gonna subtract away the original $75,000. So we're gonna say 107,482 and 97 minus the $75,000. And that shows that we have interest of 32,482 and 97 cents, because we have to take our future value here and subtract the 75,000. So I would definitely save this and mark this as a note so that you can write compound interest weekly for 52, where N is 52, and then hit save. So this was taking our future value, subtracting our principal. And so our interest is going to be $32,482.97. Let's look at, did you get it, number 3? Did you get number 3? Says, which is better investment, 3% compounded monthly or 3.25% compounded annually, semi-annually? So because we don't have an amount that we're investing and we don't have a length of time, we're really just going to use our effective interest rate to compare these. And remember, our effective rate is the simple interest rate that you would have to get to compare on apples to apples on the compounding. So this is all about effective rate. And let's write that formula down. That formula is here on page 276. And E is the effective rate. N is the number of times that you're going to be compounding per year, as it was in the other formulas. And R is your interest rate again. So we're going to compare 3% compounded monthly. So that means we'll say E1 for the first situation is 1 plus 0.03. Compounded monthly means it's 12. So we also have 12 in the monthly in the exponent spot. And then we're going to compare that to 3.25% compounded semi-annually. Semi-annually means you're going to do it twice a year. So let's head to Desmos to compare these two. So the first one is 1 plus. So the first one, the effective rate is 0.0304. Always go out to 4 decimals so that you can compare them adequately. And I'm going to copy that and paste below just to be more efficient and change my interest rate. And then also change my compounding. And remember to change your compounding in both places. And so the second effective rate is 0.0328. So let's go ahead and write those on paper so we can compare. So it looks like the effective rate of the second situation is better, even though we're only compounding twice a year with a semi-annual. The little bit interest rate that's a little bit higher is going to benefit us more. And then looking at the last, did you get it? It says, find the future value of a $40,000 investment with 6.9% interest compounded continuously 25 years after it started. So compounding continuously is a new formula that we learned. That is A equals P times E to the RT. Where this E we learned is this continuously compounding piece right here. Okay. So A is going to equal 40,000. And then E, when you type E in Desmos, it knows to use that approximation of 2.718. And then the rate was 0.069. And we're going to multiply that times the 25 years. So let's go ahead and move to Desmos and calculate that. And so 40,000. And then E, and notice the E is in italics, and that's because it knows to use the 2.718. And then shift and 6 for the exponent and parentheses. So 0.069 times 25 years. And so after 25 years, that $40,000 investment would have $224,500.84. And that concludes the Did You Get It for lesson 3.2. Catch me back for some more help.